Hello everyone, welcome to this video. In this video, we'll be solving example from the miscellaneous examples, right? So here the question is, if P, Q and R, they are given to be in GP, this thing is given to us. Further, we are given that the equation Px square plus 2qx plus R is equal to 0, and this equation dx square plus 2ex plus f is equal to 0. They have the common root. So whatever is the solution to this one, the same we have the solution for this one also. In that case, what we need to prove? We need to prove that these three things, d upon p, e upon q and f upon r, they are in AP, right? Now, in order to show that all the three numbers they are in AP, what we need to prove? We need to prove their ratios. Sorry, not their ratios, but their common difference, because we are talking about arithmetic progression. So their common difference should be the same. So that means when you subtract E upon Q, from E upon Q, you subtract D upon P, that means this thing, that should be exactly equal to when you subtract E upon Q from F upon R. So this is exactly this thing. So let's mark this as equation 1, and this is what we wanted to prove here, correct? Okay, now because we are given that this PQR, they are in GP, hence they would have this common ratio. So that means P upon Q would be equal to this R upon Q, right? So Q upon P is equal to R upon Q. Let's mark this as equation 2. This is given to us. Now let's calculate what is the root of this particular equation and this particular equation, so that we may equate them in order to reach at our result. So the root of any quadratic equation, you know, it is given by the formula x is equal to, if the equation is given to be like this, ax square plus bx plus c is equal to 0. In that case, the solution is minus b plus by the square root of b square minus 4ac upon 2a, right? This is the solution. So in this manner, here your b is this one, so you have minus 2q here plus by the square root of the square of this thing minus 4 into this divided by 2 into the coefficient of x square, which is p, correct? So you have this as the root of the first equation. Similarly, you can calculate the root of the second equation. You would have minus 2e plus by the square root of 2e square minus 4 into d into f, right? Divided by 2 into the coefficient of x square, which is d, correct? Now, because it is given that both of these roots, they are the common roots of both the equations, so they should be equal to each other, hence we can equate them. When you equate them, you have this thing, correct? So you can here it would be 4 when you open up the square, here also it would be 4 when you open up the square, and then you can take out 4 outside, so that it would be 2, right? So this and this would be not be there, this and this would not be there, 2 would be taken outside, then you can take 2 common and cancel it out here also. So all the 2's are eliminated here, so you will be left with minus q plus by the square root of q square minus pr divided by p, that is equal to minus e times of e square root of e square minus df divided by t, right? This expression. Now, because we are given that these members q, p and r, pqr, they are in GP, hence we are given this that q upon p is equal to r upon q. From here you see q square is equal to rp. So from here this q square minus rp should be equal to 0. So we can substitute 0 here, and 0, if you substitute it 0 here, you would have this thing minus q upon p, this is equal to whole of this thing, correct? Okay. Now what we can do, we can cross multiply d and p on both sides, so that we would have minus qd, this is equal to minus ep plus minus p into square root of e square minus df. We can shift this ep to the left hand side, so we have this thing. Then we can square both sides because we wanted to eliminate the square root. So it would be the square of this and the square of this, which would be e square p square. Now opening up the square of this thing, so it would be e square p square plus q square d square minus 2epqd, that is equal to p square and this thing without the square root, correct? Okay, then we can simplify it further. We can open up this bracket here and here. You would have two terms. So this term here cancels with this term. So you would be left with this term, and this term. So three terms, correct? This expression. Now you see from here you can take d as common. So 1d would cancel with 1d here. So you'd be left with q square 1d, 1 power of d, p square, no d, and 1 power of f, and this thing, correct? Now we have this expression. Now what we wanted to prove, you can have a look here at equation 1. We wanted to prove something such that we would have d upon p in it. So in order to obtain d upon p, we have d into this expression. So in order to obtain d upon p, let's give it a hit and try by dividing by pq square, because when you divide this term by pq square, q square and q square would be cancelled and you will be left with d upon p, and this is what we want for our solution, correct? So we give a hit and try by dividing by pq square, and let's see, do we reach at some solution? So when you divide by pq square, you would have this thing. Now let's cancel the common terms. So here you see this p and p gets cancelled, q cancels with 1 power, so you'd be left with minus 2, not minus 2, 2e divided by q, this term, correct? What about this term? Here q square and q square gets cancelled, you are left with d upon p. What about this term? Here 1 power of p is cancelled, so you will be left with pf divided by q square. So let's have a look. Do we have something of our kind, which is given in equation 1? E upon q minus g upon p is equal to f upon r minus e upon q. This term is there, this term is there, this term is there. What about this term? F upon r, it is not present here. So f upon r is missing. So here also we have to make use of the given thing that the numbers p, q, r are in GP. If they are in GP, that means this q upon p is equal to r upon q, or from here you have the value of r as q square upon p. So using this thing here, instead of this p upon q square, you can write 1 by r, right? This is what we have done here. So from here you have this, and you can expand this term e upon q plus e upon q. Now what you can do, you can shift all the terms. You can take 1 e upon q to this side, and you can shift this g upon p to the right hand side, so that we have this expression, and this is what we wanted to prove here in order to show that these three members, they form an AP, and this is what we wanted to prove here. So I hope you understood this question well. That is it for this video. Thank you for watching.